There are 5 persons P, Q, R, S, T. So 5 persons P, Q, R, S, T. Try to read the question and try to figure out what exactly the answer is here. One is a footballer. So we have a footballer, and there's a cricketer, and we have a table tennis player. P and S are unmarried ladies. So P and S, they are unmarried ladies. And they do not take part in any of this game. So, well, they don't participate in football, cricket, or table tennis. None of the ladies play football or cricket. None of the ladies play football or cricket. Well, do you see any kind of a logical confusion here? These are unmarried ladies. They don't take part in any game. And none of the ladies play cricket and football. So none of the ladies play cricket and football means these 2 ladies, anyhow, they are not going to play cricket and football. These 2 unmarried ladies. But if there is any other lady who is a married lady or any other lady other than P and S, even they don't play football and cricket. That is what the second sentence says here. Second paragraph, second sentence. There is a married couple in which T is the husband. So there is a married couple among these 5 persons. So T is the husband. And P and S are unmarried. So they are not the wife of, they cannot be the wife of T. So P and S cannot be the wife of T. Well, T is the husband. Then the only possibility is Q and R. One among Q and R would be the wife of T. Well, T is the husband. Q is the brother of R. Well, Q is the brother of R. Q is a male. Then Q cannot be wife of T. The only person who is the wife of T must be the R. From here itself, we can get who is the wife of T. Wife of T is R. Anyhow, then Q is neither a cricketer nor a table tennis player. So Q is a male because Q is the brother of R. And Q is neither a cricketer nor a table tennis player. Then what else he plays? Is it football or any other game? Anyway, we'll make an arrangement of this question. Who is the footballer? That's the first question. And we have few more questions. See that second question based on this, it's who is the table tennis player? And who is the cricketer? And well, who is the wife of T? That answer we already got, right? So who is the wife of T? That must be R. Okay, fine. Now, 3 ladies in the group. Who are 3 ladies in the group? We know that P and S are the 2 ladies in the group, right? And how many answer choices with P and S? Well, this is one of the answer choices with P and S. And this, we don't have P. This one, yes, P and S. However, P and S, at the same time, we know that T is the husband of somebody. So T is not a female. So this cannot be the answer choice. Then the only answer choice with P and S. Why it is P and S? P and S. P and S are 2 ladies. It is clearly given in the direction itself. So then, when we are looking for 3 ladies, P and S must be among the 2 ladies. Among those ladies group, right? This case, we don't have S, so that cannot be the answer. This case, we don't have P, that cannot be the answer. Here we have P and S is here, but T is the husband of someone, so T cannot be a lady, so that cannot be the answer. Naturally, which one is the answer? P R S. And previous case, who is the wife of T? We already got that answer. It's R. Right? Okay, fine. Anyhow, so we'll make an arrangement. Then you'll get a clear idea about what exactly it is. So let's go for the arrangement. First, I'll show you how to make the arrangement. I'm pretty sure at least some of you have made that arrangement already, either in your mind or maybe on a piece of paper. Doesn't matter. If you can make the arrangement in your mind, you can just kind of like visualize it. That's best. If you cannot visualize, then make it on a piece of paper. I'll show you how to do it. Okay, let's look at this. 5 persons P, Q, R, S, T. So we'll make a table. P, Q, R, S, and T. Oh, I'm just missing Q there. Right, so P, Q, R, S, and T. So, well, what is the agenda? First of all, we write the agenda. and the game they play. Game. We know that P and S are ladies, so unmarried ladies, so they are spinsters. Unmarried ladies, we call them spinsters. So this one, P and S, they are both are spinsters. And T is a husband, so T is a male. T is the husband of somebody. It is clearly given. There is a couple, T is the husband. And Q is the brother of R, so Q is a male as well. Then the only females in the group are P and S. P and S, then we have R as well. So P and S are unmarried, so they cannot be the wife of T. The only person who can be the wife of T is R. So R is the wife of T. Now we look at the games they play. It says that P and S, they do not take part in any game. So they don't play any game, right? P and S. And at the same time, ladies, they don't play football or cricket. So R is the another lady, third lady in the group. She cannot play football or cricket. That's a case. And Q is the brother of R, is neither cricket nor table tennis. So Q doesn't play cricket nor table tennis. And that case, who can play the football in this group? The only person who can play the football in this group is Q, because Q cannot play cricket, table tennis. So the only game Q can play is football. And ladies cannot play football or cricket. That means R cannot play football or cricket. Then football is already allotted for Q. Now what is left out is cricket. So cricket can be allotted for T. T is a male. Well, naturally T can play cricket. Ladies cannot play cricket and football. So football and cricket are allotted. What is left out? Table tennis. Well, R plays table tennis. TT. So this is what we have now. This is the arrangement we have now. Once you get the arrangement, we will answer the question. So who is the footballer in the group? The footballer in the group is Q. So the answer is Q. Next one. Who is the table tennis player? Table tennis player, it's R. See that? R is a table tennis player. Now, who is the cricketer? T is the cricketer. Next one. Who is the wife of T? We have already seen that wife of T is R. Now, three ladies in the group. We have P and S are two unmarried ladies, and R is a married lady. So three ladies in the group is P, R, S. So take a look at this one. Similar question, data sufficiency question. Direction for the questions 11 and 12. 12 we have solved. This is question number 11. And well, the same directions. If data in statement 1 alone is sufficient, then you have to answer as 1, etc. Now, what is it? A and B are two sisters, and P is A's friend. And N is P's brother, and X is M's best friend. So try to understand that question. A and B are two sisters. Okay, so let's draw it like this. A and B, these are the sisters, and both are female since they are the sisters, A and B. And well, P is A's friend. We have P. P is the friend of A. And the gender of P, we have no idea. It could be male or female. P is A's friend. So there is a link between them, friendship link. And N is P's brother. So P has a brother, N. Since it is given as brother, so N must be a male. X is M's best friend. X is M's best friend. So who is X? We have no idea. X is M's best friend. And who is Y's friend? So where is Y? Y is not really mentioned anywhere here. Who is Y's friend? That is what the question. And look at the statements. First statement. y is the sister of x. Okay, y is the sister of x. Y is the sister of x. However, the question is what? Who is y's friend? And who is the friend of y? We have no idea. We know that x has a friend m. And y is the sister of x. And it doesn't mean that y has the same friend which x has. Because in this case, see that a and b, they are sisters, correct? But a has a friend b, doesn't mean that b has the same friend. So in this case, the friend of y, we have no idea who is that. 1 alone is not sufficient. Now look at 2. This is statement 1 alone. Now we have to take statement 2 alone. Z is very close to 1 of x or y. That means Z is very close. Very close means it could be a close relation or it could be a close friendship. We have no idea. And still it is not clear whether Z is close to x or y. Well, it's clearly given that it is 1 among x or y. Is it x or is it y? We have no idea. X has a friend y, and x can have another friend z as well. Right? So that's a possibility. So, second statement doesn't say that x is a close friend of y. So, who is a friend of y? We have no idea. So, second statement is not sufficient. Second statement alone is not sufficient. Now we have to combine 1 and 2. When you combine 1 and 2, well, from the first statement, y is the sister of x. That's fine. And second statement, z is close to x or y. Even though y is the sister of x, z can be close to either x or y. So even if you combine 1 and 2, we don't get a clear idea who is the friend of y. That's the situation we have. So that means, what would be the answer? The data in both statements together is not sufficient to answer the question. So 3 is the answer for this one. This is pretty much, it is known as, data sufficiency question. Data sufficiency questions, first of all, you need to have an idea, what is a data sufficiency question? I'll give you an example for that. Now, the question is, what is the area of the rectangle ABCD? What's the area of the rectangle ABCD? Well, everybody knows that the area of the rectangle is what? Length into breadth. If you know the length and if you know the breadth, it is good enough. Okay, now we look at the statements. Statement number given in such a way that, first statement, the length of the rectangle ABCD is 8 centimeters. Number 2, the breadth of the rectangle is 2 centimeters less than the length. Now, what you need to find out here, the question is, what's the area of the rectangle? And we have 2 statements given, or these are known as the data. You need to check the data and whether this given data is sufficient or not in order to answer this question. Well, in order to answer this question, we need 2 parameters, right? Length and the breadth. Well, you get the length of this rectangle from where? From the first statement. So if you take first statement alone, you get the length, but we have no idea what is the breadth. So 1 alone is not sufficient. Statement 1 alone is not sufficient. Same way, if you look at the second statement alone, well, look at this. If you look at the second statement alone, the breadth of the rectangle is 2 centimeters less than the length. So what is the length of the rectangle? We are not looking at the first statement. We are just looking at the second statement alone. If you just look at the second statement alone, second statement alone, you cannot get the length and breadth together. So second statement alone is not sufficient to answer the question. Now we have to look at both statements, 1 and 2 together. If you cannot get the answer from the first statement alone, if you cannot get the answer from the second statement alone, you have to combine, or you have to consider both at the same time. So now length is 8 centimeters. And the breadth of the rectangle is 2 centimeters less than the length. So that means breadth would be 6 centimeters. So you got the length and you got the breadth. So ultimately, answer for this question, in order to answer this question, we need the statements 1 and 2 together. 1 alone is not sufficient, 2 alone is not sufficient. Okay, let me modify this question a little bit. Okay, so the length of the rectangle ABCD is 8 centimeters. So 1 alone is not really sufficient. We have no idea what is the breadth. And look at the second statement alone. The breadth of the rectangle is at least 3 centimeters less than the length. If you look at the second statement alone, we have no idea what is the length because we are not really looking at the first statement. So second statement alone, we have no idea what is the length. Without length, we cannot find the breadth because it is given that 3 centimeters less than the length, right? At least 3 centimeters less than the length. So 2 alone is not sufficient. Now we combine 1 and 2. Well, from the first statement, you get the length, 8 centimeters. And from the second statement, the breadth. So length is 8. So breadth is what? At least 3 centimeters less than the length, right? So breadth is what? 5 centimeters. So 8 into 5, 40. Is that the area of the rectangle? Well, it is given that at least 3 centimeters less than the length. At least 3 centimeters less than means either it is 3 centimeters less or it is more than 3 centimeters less. So 3 centimeters less, 4 centimeters less, 5 centimeters less, etc. So in that case, the breadth could be either 5, or if the length is 8, breadth could be 4, or if the length is 8, breadth could be 3, or the length is 8, breadth could be 2. There are many possibilities. So that means the area of this rectangle would be either 40, or it is 32, 8 into 4, 32, or 24, or 8 into 2, it is 16, or 8 into 1, it is 8. Different possibilities. Do we get a specific answer? Absolutely not. So even if you combine statements 1 and 2 together, it is not possible to find the answer here. So 1 and 2 together, the statements 1 and 2 together are not sufficient to give the answer for this question. So this is pretty much a simple example of data sufficiency questions. So now we go for the question which is in the question paper. This is what it is. A child wants to buy 4 toys from a shop. Read that question. A child wants to buy 4 toys from a shop. His dad is not allowing him to buy the gun in the shop. Okay, the dad is not allowing him to buy the gun. So he cannot buy the gun. And the dad has told him to buy anything else, any toy other than the gun would be okay with the dad. So the child is allowed to buy any other toy. The stock of dolls is no more with the shopkeeper. So there is no doll in the shop. So the child cannot buy the gun. The child cannot buy the doll. So gun is not allowed and doll is not in the shop. So the child cannot buy the gun and doll. Now, which toy will the child surely buy? The child wants to buy 4 toys. Among that 4 toys, the question is, which toy will the child surely buy? We are looking for just one toy that is 100% sure. That means the child buys 4 toys, but we are not sure which are the toys he buys or she buys. But what we are looking for, that one toy we are 100% sure about. Now look at the data, statements. This is statement number 1, this is statement number 2. Look at the first statement. The boy is found. It is not really found, it is found. Fond of toy cars. The boy really likes the toy cars. Does it really mean that he definitely buy that? Not sure. Well, even some of us are really fond of expensive cars, right? Some of you like BMWs, some of you like Mercedes-Benz, some of you like many other Porsche, those kind of cars. We like those cars, we are fond of those cars, doesn't mean that we are capable of buying it or we may buy it. Correct? So, child is fond of that toy cars, but we are not 100% sure. There is a chance he may buy it, but we are not 100% sure. So, 1 alone is not sufficient. Now we have to look at 2 alone. When you look at 2 alone, the toy car that the boy selected in the shop was most costly, or that's the costliest car. Well, which car? The toy car that the boy selected. Now we are not really looking at the first statement. Always remember that we are not really looking at the first statement. So ignore the first statement. Assume that the first statement is not here. Just look at the second statement. When you look at the second statement, the toy car that the boy selected. Okay. So see that? What does the statement says? The toy car the boy selected. That means it's clearly given in the statement that boy selected that toy car. So which is a toy definitely the boy has bought? That must be the toy car. So from statement 2 alone, we can get that. Without statement 1, we can get the answer from the statement 2. So statement 2 alone is sufficient. So look at that. What is the final answer? If the data in statement 1 alone is sufficient to answer the question, then you have to mark the answer as 1. Mark the answer as 2 if the data in the statement 2 alone is sufficient. Mark your answer as 3 if the data in both statements together is not sufficient to answer the question. And mark your answer as 4 if the data in both statements it is required to answer the question. So this case, which is going to be the answer? Well, 1 alone is not sufficient, but 2 alone, statement 2 alone is sufficient to answer the question. That means if the data in the statement 2 alone is sufficient to answer the question, so this question, what would be the answer? 2 would be the answer. That's the case. I'm pretty sure you have seen this kind of questions, 5, 9, 15, 23, 33, etc. These are known as number series questions. How do we deal with this number series questions? And this is number series question. So every number series question, there is a pattern. So if we can find out what exactly the pattern, it's easy for us to deal with the number series. So I'll just give you a couple of examples. Let's say 12, 14, 17, 21. And probably you know the next number, right? So what is it? 26. And what is next? So this case, what is a pattern? This pattern is what? 12 plus 2 is 14. 14 plus 3 is 17. 17 plus 4 is 21. And 21 plus 5 is 26. And 12. If it is, differences are 2, 3, 4, 5. Next one must be 6. So 26 plus 6. How much is that? 32. So this is one of the patterns. This is one of the pattern we have in number series. So the differences are consecutive natural numbers or counting numbers. Sometimes these differences are prime numbers. For example, 2, the next difference is 3, next difference is 5, next difference is 7, etc. We'll take an example for that. 12, 14, 17 is 22, 29. What's the next number? So this case, differences are 2, and this is 3. 14 plus 3 is 17. 17 plus 5 is 22. And 22 plus 7 is 29. So the differences are 2, 3, 5, 7. Next difference is 11. So 29 plus 11. The reason? These are consecutive prime numbers. 2, 3, 5, 7. Next prime number is 11. So 29 plus 11, it's 40. Well, these are the two patterns we have here. That is what? The first number plus something is the second number plus something is the third number. So that numbers are in some kind of a pattern. Either these are natural numbers or these are the prime numbers. We'll take a couple of more examples. Look at this question here. 24 and 35, 48, 63. What's the next number? This case, if you take differences, what you see here, the differences are, the first difference 11. 24 plus 11, 35. 35 plus 13 is 48. 48 plus 15 is 63. So these numbers, 11, 13, 15, these are consecutive odd numbers. Next odd number must be 17. Well, 63 plus 17 is 80. That's one way of looking at this question. However, if these numbers are quite large, for example, instead of 24, if it is 325, if it is 362, etc., that's a bit more larger numbers, right? 3-digit numbers. So that case, finding these differences would be a little more time consuming. So that case, we have another method or another pattern we can find out from this question here. So you look at 24, you look at 35, 48, what exactly comes to your mind? When I look at 24, well, I visualize a number near to this. It's 25. And 35, then I visualize another number which is near to that, 36. And 24 is actually 1 less than 25. 25 is 5 square. So this is 5 square minus 1. And 35 is 1 less than 6 square. 6 square minus 1. And this one is 7 square minus 1. This is 8 square minus 1. See that? 5 square minus 1, 6 square minus 1, 7 square minus 1, 8 square minus 1. Next one is 9 square minus 1. 9 square minus 1, 9 square is 81, 9 square minus 1 is 80. Well, if you look at the answer, look at the other pattern, like plus 11, plus 13, the differences are plus 11, plus 13, plus 15. Next one is 63 plus 17. Then you get the same answer, 80. Is there any other pattern possible for this question? Take a look at this. Well, I show you one more thing. At the same time, in between, when I get the board ready for that, you can just think about it. Is there any other pattern we can have here? There is another pattern. What is in front of us is 24 can be written as 4 into 6. And this is 5 into 7. See that? 4 into 6. 5 into 7, and this one is 48. What is it? 6 into 8. See that? 4, 5, 6, 6 into 8. Next one, 7, 7 into 9. Then next one is 8, 8 into 10. So still we get the same answer. So we see that 3 different patterns here. And we'll have more varieties of pattern from number series. One more pattern I'll just show you. You never know what kind of pattern it's waiting for you in the actual exam. So that's the reason we are taking different patterns here. Another pattern we have from number series is something which is related to the cubes as well. So we'll take a look at that. What is that? Something related to cubes. Here it is. Let's say 7, 26, 63, and 124. Or what's the next number? You can just think about differences. You can think about any other pattern. You can think about squares. So, nearest square is 3 square minus 2, and 5 square plus 1. And this one, 63, nearest square is 8 square minus 1. And 124 nearest square is 11 square plus 3. However, 3 square minus 2, 5 square plus 1, 8 square minus 1, 11 square plus 3. Is there a pattern? Not really. If it is, let's say, 3 square minus 2, 5 square minus 2, 8 square minus 2, 11 square minus 2, then that's a pattern. Or if it is 3 square minus 2, 5 square plus 2, 8 square minus 2, 11 square plus 2, still that's a pattern. Alternative plus and minus. But this case, we don't have a pattern. So the squares doesn't help us in this case. Now think about cubes. Well, when I see that 26, I see that it's 3 cube minus 1. And 63, 4 cube minus 1. And 124 is 5 cube minus 1. See that? And this one is 2 cube minus 1. 2 cube is 8. 8 minus 1. This is 3 cube minus 1. 2 cube minus 1, 3 cube minus 1, 4 cube minus 1, 5 cube minus 1. Naturally, the next one must be 6 cube minus 1. 6 cube is 216. So 216 minus 1 is 215. So that's the answer for this one. Now we look at the question right here on the board. What would be the pattern and what would be the answer? Relatively simple question. We'll take a look at that. Hope you can see this question. Yeah, this is large enough for you to see that. So this is a question number. And 5, 9, 15, 23, 33. What is the next number in the series? You can see that 5 plus 4 is 9. 9 plus 6 is 15. 15 plus 8 is 23. And 23 plus 10 is 33. So 4, 6, 8, 10. 33 plus, next one must be 4, 6, 8, 10. Next one is 12. So 33 plus 12. The answer must be 45. Simple question. Okay, so let's move on to the next type of questions here. Now we have, this one. This is a blood relation question. This is another interesting one we have. We'll take a look at this. If Amar is the son of Mohan and Mohan is the son of Sohan, then how is Sohan related to Amar? So what type of question? It's blood relation question. Blood. So Amar is the son of Mohan. So how do you indicate that relations, blood relations? Well, we know that blood relations. We heard a lot of blood relations when we hear the other people talk in your home. Let's say your parents, your grandparents, your cousins. Especially when you go for a wedding or a family function, you hear a lot of relations, right? So my brothers, cousins, wives, husbands, son, etc., or my grandfather's brothers, daughter's son, or my brother's daughter's younger son. So these kind of relations, you see that. So if that's a relation, so what exactly it represents, or how you formally represent that? Think about it. What's the relation between you and your father? It's your father, right? However, it can be expressed in blood relation as your father can be your mother's husband as well. Right? Your mother's husband. Or it could be your mother's father-in-law's only son. Your father can be your mother's father-in-law's only son. Or your father can be your sister's grandfather's, paternal grandfather's only son. Your sister's paternal grandfather's only son. That is your father as well. So the father, we have a direct relation with the father. However, it can be represented in different ways. That is what exactly comes in the blood relations. Some of the questions are straightforward. It's pretty easy for you to understand and pretty easy for you to get the answer. Some of the questions are a bit complicated. Now, how do we represent these relations, blood relations especially? So if you have a specific method to represent that blood relations, it is easy for you to understand those questions. For example, A. Well, A has a child B. A has a child B, or A is the mother of B. So if A is the mother of B, how do you indicate the relation? A is the mother of B. Can we mark it like this? Or A is the mother of B. Or A is the mother of B. What is the best way to represent this relation? In this case, if A is the mother of B, A is from the previous generation and B is from the next generation. So in that case, it is the best way to represent the relation between A and B. This is what? A is the mother and B is the child. And if you know the gender of any of these persons, mark it as it is. For example, like A is the mother. It clearly says that A is the mother. So A is the mother So this is the symbol I use to indicate females. You can follow the same pattern, or you can have another symbol to indicate the female. But always use the same symbol to indicate all the females. Otherwise, it would be confusing. So here it is. A is the mother, and B is what? B is the son or daughter? Is it given there? Not really. A is the mother of B. So B is the child. What is the gender of B? B could be male or a female. We have no idea. And B has a brother K. B has a brother K. Since it clearly says that K is the brother of B, K is a male. Correct? Now, K has a sister F. So F is a sister, so that's a female. So now you see that B has two siblings, K and F. Or A has three children, B, K, F. And the father of F is G. So father of F is G. So father is a male. So this is a symbol to indicate a male. This is a symbol to indicate the male. Now if you see that A is the mother of these three children and G is the father of these three children, then definitely A and G are the couples, the parents. Now what is the relation between A and F? So we'll just take a look at that. What's the relation between A and F? Usually they ask the question something like this. How is Sohan related to Amma? Same similar way, how is A related to F? In this case, how is A related to F? Always remember one thing, who is immediately before the question mark? That's F, correct? And from the point of view of F, who is A? That's a question we have. So from the point of view of F, who is A? Mother. So in this case, the answer is mother. And this question can be slightly different. Something like, how is F related to A? F related to A, that means from who is immediately before the question mark? A. From A's point of view, who is F? From the point of view of A, who is F? F is a child of A. At the same time, F is a female. So what is the answer? Daughter. See that? Now we'll take a look at the relation between this G and K or G and B. So how is G related to B? Look at that. This case, who is immediately before the question mark? B. From B's point of view, who is G? B's point of view, this is B. B's point of view, G. B is the child and G is the father. So father is the answer. Enough. Another one we have. Let's write it this way. How is B related to G? Now, G's point of view. Look at G's point of view. Who is B? G is immediately before the question mark. From G's point of view, who is B? From G's point of view, B is the child, right? At the same time, we are not sure what is the gender of B. The beginning of the question says that A is the mother of B. So A is the mother and B is the child. While B is male or female, it is not given to us. Still, we are not sure about whether B is male or a female. So in this case, if you have an answer choice, child, that is correct. But for normal case, the exams, they don't give you an answer choice child. Instead of that, the answer choices would be given as slightly different. What would be the possible answer choices you can expect here? The answer choices you can expect in this case are normally the 4 answer choice. The first one, daughter. And second one, cousin. And third one, son. And the fourth one, data inadequate. Among these 4 answer choices, how is B related to G? From G's point of view, who is B? G's point of view, who is B? Well, is it a daughter? No, we are not sure about it. It could be. There is a possibility, but we are not 100% sure about it. And is it a cousin? No, it's not the cousin. So that cannot be the answer. Son, yeah, it is a possibility again, because it's a child, right? So child can be son or a daughter. So there are 2 possibilities. Either it's a daughter or son. But we are not sure about. From the given data, we are not sure about whether it's a son or daughter. So finally, the answer for this question, the best answer for this question must be data inadequate. Hope you got an idea about what's this blood relation type questions, right? So now we'll solve this question right here. So let's go for it. We use the same method we have used for the previous example. If the Amar is the son of Mohan, if the Amar is the son of Mohan, so we'll take Amar here. Amar is the son of Mohan. So Amar is the son. So A is male. And Amar is the son of Mohan. Mohan, is it a male or a female? Usually, you know what, Mohan, that name indicates a male, but we are not sure about it. There are names called Mohanawali. So is actually, this Mohan is a short form of Mohanawali, then this could be a female. So we are not really sure about what is the gender of Mohan. From the name, we cannot really assume that the gender is male or a female. In this case, the case of Amar is clearly given. Amar is the son. So, well, if it is son, that's a male. Now, Mohan, Amar is the son of Mohan, and Mohan is the son of Sohan. Of course, Mohan is the son of Sohan. Then we can say that, yes, Mohan is the son and it's a male. Mohan is the son of Sohan. Now the question, what's the gender of Sohan? Is it like a male or a female? We are not really sure about it. Sohan could be male or a female. From the name, possibly you may have a feeling like most of the time you see that the name Sohan indicates a male, right? Well, it could be, but we are not 100% sure about that. So we'll put a question mark here. Gender, we are not sure about it. Now the question, then how is Sohan related to Amar? So from the previous experience, you remember how you interpret this question. How is Sohan related to Amar? So we'll take it from the person who is immediately before the question mark. That's Amar. From the point of view of Amar, we'll go for Sohan. Okay? So from the point of view of Amar, who is Sohan? From the point of view of Amar, who is Sohan? Well, his father's parent. Amar's father, Mohan's parent. Since I say the parent, because I am not sure whether the Sohan is a male or a female. So either father's mother, Sohan is Amar's father's mother, or father's father. So it is either grandfather or grandmother. There are 2 possibilities. So the answer must be either data inadequate or it could be cannot be determined. So data inadequate and cannot be determined are in the same meaning. We cannot find which one is the answer. Well, we have 2 answers possible, so we cannot say which one is the exact answer. It could be grandfather or it could be grandmother. There are 2 possibilities. That is what it is for this question. That's a blood relation question. Now, what is it? Here, 16. We'll take a look at that. It's a blood relation related question. A at B. See that? A at B means A is the sister of B. We just write and interpret that question. A at B means A is the sister of B. A is the sister of B. Who? A. At case, A must be a female. Now, A minus B means A is the brother of B. A minus B means A is the brother of B. So that case, A must be a male. Then, M is the angle of P is denoted by what? M must be the angle of P. So if M is the angle of P, well, angle means either your mother's brother or your father's brother. That must be your uncle. Nobody else. In blood relation, nobody else is your uncle. Your cousins, sometimes we call our cousins uncle. That's okay. You can call them uncle. But according to the blood relation definition, your uncle is your father's brother or your mother's brother. Nobody else is your uncle. So in this case, uncle is the brother of the father or the brother of the mother. That means uncle is a male. One thing we are 100% sure, M is the uncle. So M must be a male. So M is the uncle of P. Will be denoted by any of these answer choices. So which answer choice? So here we do trial and error. That means we just verify each answer choice and we eliminate which are not the correct answer choices. So we'll take a look at that. M at K means, well, M at K means M is a sister of K. That case, M is a female. That cannot be the answer because we need M as the uncle. M must be a male. K minus P at M. So, well, K minus P at M means K is the brother. K minus P means K is the brother of P. Correct? K is the brother of P. And P is the sister of M. P is the sister of M. That means K, P and M are siblings. If three of them are siblings, you cannot call your sibling as an uncle, right? So that is not the relation. So this cannot be the case. Now MKP. MKP means, M minus K into P. Well, that relation into this relation is not mentioned in the question. And well, M minus K is given. M minus K is given. M is the brother of K. So M is the brother of K. M is a male. M is the brother of K. And if K has a child P, then M must be the uncle of P. That's a possibility we are not really 100% sure about. So this answer choice is possible. Now before confirm it, we have to check that answer choice as well. So here M into K. M into K, this relation multiplication symbol is not defined in the question. So M into K means, well, M is a male or a female, we are not really sure about it. Then K minus P, K is what? K is the brother of P. If K is the brother of P, then M is who? M could be what? M must be the uncle. If K is the brother of P, K and P are brothers, then M cannot be the uncle. If K is the mother or father of P, then, well, M can be the brother of that K. In that case, M can be the uncle. But in this case, K and P are at the same gender. They are siblings. So, anyhow, this cannot be the answer. The only answer choice we have left out is M minus K. That means M is the brother of K. And K must be either the father or the mother of P. However, that part we are not sure because this symbol, multiplication symbol, is not defined. That means multiplication symbol represents what kind of relation. It is not really defined in this question. So we are not really sure about K is the mother or father of P. However, there is no other possibility we have among the answer choice. That means this is the only possible answer we have. So that's the answer. So, which relation represents M is the uncle of P? This is the only relation that can represent. We are not 100% sure about it. That's the only possibility we have here. All right. Now, let's move on to the next question. These are some of the interesting questions here. Statement and conclusions type questions. So what exactly they are? Have you seen these questions earlier? These are known as syllogism or deductions type of questions. So directions for these questions are given here. Question 17 to 20. In the following questions, there are two statements followed by two conclusions numbered 1 and 2. You have to take the given statements to be true even if they seem to be at variance from commonly known facts. Read the conclusions and decide which of them logically follows. So here, mark your answer as 1 if only conclusion 1 follows. Mark your answer as 2 if only conclusion 2 follows. Mark your answer as 3 if both conclusions 1 and 2 follow. Mark your answer as 4. Neither conclusion 1 nor 2 follows. So these are the answer choice marking method. Now we look at the statements. Well, what are the statements here? Let's take a closer look at. All Indians are not intellectuals. Some intellectuals are fools. Interesting. Now conclusions. Some Indians are not intellectuals. All intellectuals are fools. First of all, you need to have a pretty good idea about what are the type of statements used in this kind of questions. That means these questions are known as either syllogism or deduction type questions. Okay, so there are in syllogism or deduction, in order to solve these questions, you have 4 standard statements. Which are the 4 standard statements in syllogism? We'll take a look at this. All statement, some statement, no statement, and some not statement. In order to get a clear idea, I'll make a complete statement using all. For example, all cats are dogs, and some cats are dogs, and no statement means no cats are dogs. And some cats are not dogs. Some cats are not dogs. So these are the 4 types of statements we have. So all cats are dogs. It is known as a universal positive statement. So this is a positive statement. All cats are dogs. Some cats are dogs. These 2 are positive statements. And no cats are dogs. Some cats are not dogs. These are negative statements. So there are 2 terms in the statements. Look at this, all cats. And this is dogs. So cats, dogs. Second one, some cats are dogs. So again 2 terms, cats and dogs. This one we have no cats are dogs. The first term is cats, second term dogs. And some cats are not dogs. Again the first term cats, second term dogs. Always remember the first term is known as subject of the statement, and second term is known as predicate. So this is subject. Whichever comes first, that's a subject. If all monkeys are donkeys, monkeys, it's a subject, and donkeys is a predicate. If all dogs are cats, then dogs is a first term, so dogs is a subject, and cats is a predicate. In this case, cats came first, that means cats is a subject and dogs predicate. So whichever comes first, that's a subject, and whichever comes second, that's a predicate. At the same time, we need to have an idea how to draw the Venn diagrams using the statements. So these questions, in order to find out whether these conclusions follow the statements or not, we need to draw the Venn diagrams. How do we draw the Venn diagrams? So I'll show you that how do we do it pretty quick. All statement, usually we draw the Venn diagram. All cats are dogs. This is the Venn diagram for all statement. All cats are dogs. That means cats inside, dogs outside. All cats are dogs. Now some cats are dogs. This is what it is. Some cats are dogs. Now we have no cats are dogs. No cats are dogs. There is no intersection between cats and dogs. Cats and dogs are not supposed to intersect. The space arrow indicates that these 2 circles cannot intersect. Now some cats are not dogs. Some cats are not dogs. Some cats are not dogs. Well, this is what the diagram for some cats are not dogs. Cats, dogs. Some cats here, they are not dogs. However, some cats are not dogs means, let's say we have 20 cats here. if you take 5 cats from there, that 5 cats are not dogs. Balance 15 cats we have. That 15 cats, are they dogs? Not necessarily. Some cats are not dogs means balance cats, it can be dogs or it can be some other animals or it could be something else as well. So, 5 cats, out of this 20 cats here, if I take 5 cats, they are not dogs. Balance 15 cats can be the dogs. That's a possibility. Or if you have 20 cats here, if you take 5 cats and balance 15 cats, they may not be dogs. They may be buffaloes, they could be rats, they could be elephants or anything like that. So that's a reason there is no intersection between cat and dogs here when in the case of some not statement. And these two diagrams, the diagram for the no statement and some not statement seems to be similar, but there is a logical difference. This case, the cats and dogs are not supposed to intersect. There is no way. However, this case, cats may intersect with the dogs. Cats and dogs are, it is possible to intersect. That's a possibility. But when we draw the diagram, we don't show the intersection between cats and dogs for some not diagram. But for some diagram, yes, there is an intersection between cats and dogs. So this is how we draw the diagrams to deal with these statements and to solve the statements. Okay, so let's take a look at one by one. How do we draw the Venn diagram for these statements and how do we solve these conclusions? First of all, we'll take maybe a couple of examples. All lions are wild and some wild are cruel. So these are the statements. And you may have conclusions below that. We'll take a look at conclusions later. So now how do we draw the diagram for the statements? So all lines are wild. So all statement, this is what the diagram for all statement. All lines are wild. At the same time, it says that some wild are cruel. So there is an intersection between wild and cruel. So it is clearly says that some wild are cruel. Wild and cruel are intersecting each other, but when you think or if you apply your common sense, you may have a feeling like some of the lions are cruel as well. So you may have a tendency to draw the cruel diagram touching the lion's diagram as well, right? But don't do it. Because the statement doesn't say that lions intersecting with the cruel. It says that some wild are cruel. It doesn't say that some lions are cruel. So the cruel diagram is not supposed to touch the lion's diagram. So once again, don't apply your common sense here when it comes to the deduction or syllogism questions. All other areas of logical reasoning, you apply your common sense. That is what it is required. But this area is totally different. Okay, anyhow, so that's a basic diagram or that's a diagram for these statements. Now we have conclusions. We'll take a look at what are the conclusions here. First conclusion, some cruel are lions. Now, second conclusion, some wild are lions. Now, we need to check out whether these conclusions follow the given statements or not. That is what we need to find out, whether the given conclusions follow the statement or not. So, how do we check it? This is what. Take the first conclusion. First conclusion, some cruel are lions. Look at that. Cruel and lion, there is no intersection. That means we cannot say that some cruel are lions. If the conclusion follows the statement, then the conclusion must be valid for all the possibilities. This case, in this possibility, cruel is not intersecting with the lion. In some other cases, cruel may be intersecting with the lion. That means some of the lions may be cruel. However, in order to say that some cruel are lions, we have to have 100% surety about that. That means all the possibilities, some of the cruel must be lions. But this case, we are not sure. This is clearly indicated that cruel and lion, there is no intersection. So we cannot really say that lions are cruel. So this particular conclusion, some cruel are lions, is invalid. It is invalid for the diagram we have drawn here. If it is invalid, means it doesn't follow. First conclusion doesn't follow. Now second conclusion. Second conclusion, some wild are lions. Well, all lions are wild. Some wild are lions. Is it correct? Yes, of course. This part of the wild, actually wild is the circle, and this part of the wild are lions. So then some part of the wild are lions. So some wild are what? Lions. So it is valid. If it is valid, a positive conclusion, valid for the basic diagram, then it follows. Here it's a positive conclusion which is invalid for the basic diagram, it doesn't follow. So this is what one of the simple example we can have for these type of deduction type questions. Now we get into these questions right here. Look at the statements. All Indians are not intellectuals. Intellectuals. Some intellectuals are fools. All right, so now look at the statements. All Indians are not intellectuals. Some intellectuals are fools. So first statement, all Indians are not intellectuals. What type of statement? We have 4 standard statements. All statement. We have seen that all cats are dogs. Some cats are dogs. No cats are dogs. Some cats are not dogs. Here it is, all not statement. The standard statements are all statement. All cats are dogs. It is positive. But here it is given as all not statement. All not means it's negative statement. We don't have such a standard statement. Standard statements, what we have is all cats are dogs. Some cats are dogs. No cats are dogs. Some cats are not dogs. 4 types of standard statements. Now we need to convert this statement into the standard form. So all Indians are not intellectuals. All not statement. All not statement is equivalent to no statement. So this is actually, we are converting it into a standard statement. So it becomes what? No Indian is an intellect. And second statement, some intellectuals are fools. Yeah, that is fine. So that's a some statement, that's fine. Okay, so no Indian is an intellectual. Some intellectuals are fools. So we draw the diagram. Some intellectuals are fools. This is intellectual diagram. Intellectual. Some intellectuals are fools. And no Indian is an intellectual. No Indian is an intellectual. So there is no intersection between intellectual and Indian. This is Indian. So that means intellectual and Indian cannot overlap. And at the same time, some of the intellectuals are fools. And Indians and fools, well, some of the Indians are fools. It's a possibility. They may overlap, but it is not really given as some Indians are fools. So that's the reason we have an intersection with Indians and fools. It is not given that some of the Indians are fools. There is a possibility, as you know. Okay, now conclusion. Some Indians are not intellectuals. And all intellectuals are fools. We go for the second conclusion first. Second conclusion, all intellectuals are fools. Look at the diagram. All intellectuals, are they fools? Not really. Only some intellectuals are fools. So all intellectuals are fools. It is invalid for the basic diagram. So it doesn't follow. Now, the first conclusion. First conclusion, some Indians are not intellectuals. Well, some Indians, they are not intellectuals. That's correct. Look at that, some Indians from here. they are not intellectuals. However, it is negative statement. If a negative statement, if it is valid, then we have to negate it. If it is a positive statement, if it is valid, it follows perfectly all right. If negative statement, if it is valid, then we have to negate it. When it comes to negative statement, if it is valid, it is a bit tricky. Well, we don't have a lot of time to explain all those kind of things, but however, if you are really interested to know more about it, so I'll give you a way to find it. So there is a YouTube channel called Walnut Training. Walnut Training. By the way, it's my own channel. I use this channel for the basic ideas, especially when we don't have a lot of time to discuss that in the class. You get a basic idea from here. So this is what Walnut Training, YouTube. So you Google it, you get it. Or maybe I'll arrange your coordinator to send you the link of this channel through WhatsApp or something like that. Anyhow, so this is a YouTube channel. When you look at that YouTube channel, you see a lot of classes, a lot of videos like blood relations, you may have direction sense, you may have number series, coding, decoding, a lot of that. However, our focus at this point of time, you have to look at this deduction question. So it is given as deduction 1, deduction 2, deduction 3, deduction 4, etc. So if you take a look at these videos, deduction means syllogism type questions. Deduction and syllogism, it's pretty same thing. So you look at deduction 1, 2, 3, 4, up to 5. There are 9 videos. It's not necessary that you have to look at all the videos, but at least you look at up to deduction 5. To deduction 5. So you'll get a clear idea how this, diagrams are drawn. A detailed way of drawing the diagrams is given in the channel. Here I have given you a pretty much idea, simple idea. But if you want further explore, into that, this is the best place to do that. Okay, anyhow, so deductions 5. And where you get it? You Google Walnut Training YouTube, you get the YouTube channel. So that is the best way to deal with it. Since it comes to negative statement, I'm pretty sure some of you have some kind of a confusion. So if you look at those videos, that confusion can be cleared. Okay, so now I'll explain how do we deal with negative conclusion. So here we have a negative conclusion because we have a note here. So that note indicates negative statement. Some Indians are not intellectuals. So when you look at the basic diagram, what we have drawn here based on the statements, this diagram is drawn based on the statements. So when you look at the diagram, some Indians are not intellectuals. That's correct. Some of the Indians are not intellectuals. However, that is valid. Some of the Indians are not intellectuals means given conclusion is valid. Since negative conclusion is valid, we have to negate it. We have to negate it. When you negate it, what do you get? Negation of some not statement is always all statement. Some not statement, the negation is always all statement. Some statement negation is no statement. No statement negation, some. Negation of no is some. Negation of some not is all. So this case, some not statement that is negated as all Indians are intellectuals. So that's a negated conclusion. This is the original conclusion. We have negated it. All Indians are intellectuals. So once you get the negated conclusion, we have to draw a new diagram using the negated conclusion. How do we draw it? This is what it is. All Indians are intellectuals. All Indians are intellectuals. So, well, Indians must be inside. This is intellectual. All Indians must be inside intellectuals. Indians. And what is missing here? What is it? Fools, right? So in the basic diagram, we have fools missing. And the fools is intersecting with intellectuals. Fools are not really intersecting with Indians. So we have to bring the same relation here. Intellectuals and Indians are here, but we don't have fools in the new diagram. We will bring that fools here. Then in that case, the fools are intersecting with intellectuals. So this is a new diagram. Now we need to check out whether this new diagram exists or not with the given statements. Well, the given statement says no Indian is an intellectual, right? So this case, all Indians are intellectuals. So no Indian is an intellectual, and this new diagram shows that all Indians are intellectuals. So that means this new diagram and the given statement are contradicting. It says no Indian is an intellectual. This one says all Indians are intellectuals. So these are contradicting statements. So this diagram contradicts the given statement. So we cannot tolerate that diagram, or we cannot say that the diagram exists. So this case, diagram doesn't exist. If the diagram doesn't exist, actually this diagram is drawn based on what? Negated conclusion, correct? So if the diagram doesn't exist, means negated conclusion is invalid. If negated conclusion is invalid, this is the negation of what? It's the negation of the original conclusion, the first conclusion. If this one is invalid, the original conclusion must be valid. So original conclusion is already valid for this diagram, and the original conclusion is valid for this diagram as well. And there is a peculiarity for these two diagrams. This is the basic diagram, or this is the diagram with the minimum overlap. This is the new diagram. This is the diagram with the maximum overlap. So ultimately, we prove that our conclusion is valid for the minimum overlap, and our conclusion is valid for the maximum overlap. That means our conclusion follows. Conclusion follows. So conclusion number 1 follows, conclusion number 2 doesn't follow. That's how it is. So we have another question from syllogism and deductions right here in front of you. So the syllogism or deduction. So this is what it is. Some students are hardworking. No hardworking is intelligent. So how do we deal with this question? Draw the diagram. So that diagram is known as basic diagram, diagram with the minimum overlap. That is what the diagram we draw first. And based on that diagram, we check the conclusions and find out whether these conclusions follow the statements or not. That is what we need to find out. Okay, let's check it out. Here, some students are hardworking. Some students are hardworking. And no hardworking is intelligent. No hardworking student is intelligent. This is what the statement says. Now look at the conclusion. Conclusion number 1. The students who are not hardworking are not intelligent. There are 2 negatives, right? So 2 negatives become a positive. So what do we do here? We'll cut off these negatives. So what do you have? Students who are hardworking are intelligent, or hardworking students are intelligent. Hardworking students, intelligent. There is no intersection between hardworking students and intelligent. So that means this conclusion is invalid for the basic diagram, so the conclusion doesn't follow. Conclusion doesn't follow. That is what the answer we have from here, doesn't follow. So first conclusion doesn't follow. Second conclusion, no intelligent is hardworking. Well, look at this. No intelligent is hardworking. That is correct. That is valid for the basic diagram. If it is valid, if it is a positive conclusion valid for the basic diagram, then it follows. There is a difference between valid and follows. Valid means it is valid for one situation. If it follows means it must be valid for all possible situations. That's the difference between valid and follows. This case, this conclusion is valid for this situation, this diagram. Then we have to find out whether it is valid for all other possible diagrams. There are many other diagrams possible. This is just one diagram with the minimum overlap we have drawn here. It is not practical to draw all the diagrams, so that's the reason we use this particular method. All right, now this one, no intelligent is hardworking. No intelligent is hardworking. It is valid. However, it is negative, so we cannot say that a negative is valid. We cannot say that it follows. But if it is a positive is valid, we can say that it follows. In this case, it is negative. It's valid. So we have to further investigate. So how do we further investigate? We negate it. Negation of no statement is some statement. Negation of some not is all. Negation of no statement is some statement. So some intelligent is hardworking. Some intelligent is hardworking. So now look at here. What do you have to do actually? If you have a conclusion which is negative valid, you have to negate it. Then don't check it with the diagram we have. Instead of that, what you have to do, draw a new diagram using this negated conclusion. So let's draw a new diagram using the negated conclusion. This is a negated conclusion. Some intelligent is hardworking, or some intelligent are hardworking. So some intelligent are hardworking. So hardworking and intelligent, there is an intersection. At the same time, in the basic diagram, we have three terms. Which are the terms? Students, hardworking, and intelligent. Here we have hardworking and intelligent, and here one term is missing. What is that term? Students. So look at that. Student is intersecting with the hardworking. Student is not intersecting with the intelligent. That means when we bring that student to this new diagram, it must be like this. Student is intersecting with the hardworking. So that's a new diagram. Now we need to check this new diagram exists or not with the given conclusions. Given statements. So these are the statements. So let's look at the new diagram and check out whether it exists or not. The new diagram, some students are hardworking. Well, that's correct. In the statement, some students are hardworking. In the new diagram, some students are hardworking. Perfectly all right. And second statement, no hardworking is intelligent. No hardworking is intelligent. Here, there is an intersection between hardworking and intelligent. According to the statement, hardworking is not supposed to intersect with the intelligent. But here, hardworking is intersecting with the intelligent. That means the diagram should not exist because a diagram contradicts with the given statements. Always the diagram should be in line with the given statements. It should not contradict, but here it contradicts. So diagram doesn't exist, so that means negated conclusion is invalid, and we prove that original conclusion follows for the basic diagram and the new diagram as well. That means basic diagram is the minimum overlap, this is the maximum overlap. So ultimately, well, your negative conclusion, which one? That follows. So first conclusion doesn't follow, second conclusion follows. If second conclusion follows, what is the answer? Only conclusion 2 follows. That would be the answer. Now question number 19. Well, 19, we'll take a look at that. Statement, some cats are rats. Some cats are rats, all bats are rats. So we'll draw the diagram first. All bats are rats. All bats are rats. And some cats are rats. That is not the diagram for all. The diagram for all must be like this. All bats are rats. All bats are rats. The diagram we have drawn earlier, that was a diagram for some. So this is all. All bats are rats. And some cats are rats. I'll go for statement 1 now. I have drawn the diagram for statement 2 already. All bats are rats. Now statement number 1. Some cats are rats. Some cats are rats. Okay, so that's a basic diagram. Now conclusion. Some rats are bats. Some rats are bats. That's correct. All the bats are inside rats. So some rats are bats. So it is valid. Positive conclusion valid means it follows. Now, cats which are not rats are bats. Okay, so cats which are not bats. So cats which are not rats, which are they? Cats which are not rats. These are the cats which are not rats. This blue area, these are the cats which are not rats. And it says that, the statement says that, the conclusion says that the cats which are not rats are bats. Is it correct? No, it is invalid. It is invalid. If it is invalid, it doesn't follow. Negative conclusion or positive conclusion doesn't matter. If it is invalid, it doesn't follow. So ultimately, we have only one conclusion. One follows. Conclusion one follows. The answer means you have to mark your answer choice as 1. Only one follows. All right, next one here. See that. Well, I have drawn the diagram for your convenience, but I'm just taking it off. Here, there is a minor correction on. It is given as blocks. All blocks are beautiful, but actually it is not block, it is all books. All books are beautiful. No beautiful is good. Some books are not beautiful, some books are good. So this is what the question we have. So we'll check it out. All books are beautiful. All these are books. All books are beautiful. So this is what. Now, no beautiful is good. So there is no intersection between beautiful and good. So this is good. Now look at the conclusion. Some books are not beautiful. Some books are not beautiful. Actually, all books are beautiful. It's clearly given that all books are inside beautiful circle. So, can we say that some books are not beautiful? Not really. All books are beautiful. Some books are not beautiful is invalid. And negative conclusion, invalid means it doesn't follow. If a negative conclusion is valid, then we have to negate it. But if negative conclusion is invalid, doesn't follow. A positive conclusion is invalid, doesn't follow. So if a negative or positive conclusion, if it is invalid, it is easy for us to deal with that conclusion, because if it is invalid, doesn't follow. So this case, negative conclusion, invalid, doesn't follow. Now, second one, some books are good. Look at that. Some books, are they good? There is no intersection between books and good. So some books are good, it is invalid. So positive conclusion, invalid, doesn't follow. So both conclusions do not follow. If both conclusions do not follow, then the answer must be neither 1 nor 2 follows. So the answer choice, you have to mark the answer as 4. Answer choice 4. All right, next one here. Next one, this is pretty much a coding, decoding type of questions. We'll take a look at that. First of all, I'll give you an idea. What is coding and decoding? What kind of patterns are used in coding and decoding? So we'll take a look at that first. A few examples. Let's say Gulf. So if Gulf is coded as So look at that. Gulf is called as DRIC. So there is a pattern here. We need to find out what exactly the pattern here. Once you get the pattern, there must be another word given to you. Then you can find the code for that as well. So first of all, try this one. So Gulf. Gulf is called as DRIC. Then what's the code for warm? Check it out. The best way to deal with this kind of questions is if you know position values of letters. Well, position values of letters actually, you know what, A, B, C, D alphabets, E, F, G, etc., X, Y, Z. So the position value, as you know, A, first letter. So position value of A is 1, B is 2, C is 3, D is 4, etc. This one is 24, this one is 25, this one is 26. And it is not that easy for you to by heart, and it is not really practical to by heart all these position values of letters. So we have a shortcut method for that. So what is the shortcut method? We use this word, let's say E-J-O-T. E-J-O-T. E-J-O-T means what? These are the position values of letters E, J, O, T, and Y. Now, what is G? Well, we know that E is 5, so G must be 7. U, what is the position value of U? Well, T is 20, so U must be 21. And well, J, we need to find the position value of L. We know that J is 10, so L must be 12. J, K, L. And F, E is 5, so F must be 6. Now, what are the position value? D is 4, R. Well, T is 20, so R must be R, S, T. So R must be 18. And I, J is 10, so I must be 9. So C is 3. Now, what is the pattern here? Check it out. So 7 is coded as 4. So what is it? Minus 3. 7 minus 3 is 4. That means 7th letter is G, 4th letter is D. So 7 and 4. Same way, 21 and 18, so it's minus 3. 12 and 9, so it's minus 3. And 6 and 3, that's minus 3. And 1, we use the same pattern here. So what do you get? Minus 3, minus 3, minus 3, and minus 3. W minus 3. W is 23rd letter. 23rd minus 3 is 20th letter. What is that? T. A. A minus 3. Actually, this is A. Is there a letter before that? Or think about the English alphabets this way. It is X, Y, Z. Then again it continues A, B, C, D, E, F, etc. So this one we take it as after 26, 27, 28, 29, 30, etc. So if A is here, which letter? 3 places before A. So that is 1, 2, 3. So that is X. Then R. R is 18. 18 minus 3. So 18 minus 3, of course. 18 minus 3 is 15. 15 is O. And M. M is 13th letter. 13. 13 minus 3 is 10. That's J. So T, X, O, J. This is one of the simple example of coding and decoding. We'll take a couple of more examples, then we go for the question we have right here. Another one we have is, let's say, table. Table is coded as U, C, E, P, and J. Then what's the code for chair? So look at the pattern. What kind of pattern we have here? Of course, if you want, you can think about the position values of letters as well. That would be much more easy for you to deal with this kind of questions. If you apply the position values of letters, make it fast. T is 20, A is 1, B is 2, L is 12, E is 5, etc. And assign position values for U, C, E, P, J as well. Okay, let's try this way. 20, 1, 2, 12, 5. So you have to be really familiar with the position values that make it really fast for you to deal with this kind of questions. So this one is 21, 3, 5, 16, and 10. So 20, 21. Difference is what? 1 plus 1. 1 and 3, so that's plus 2. 1 plus 2 is 3. 2 plus 3 is 5. And 12 plus 4 is 16. And 5 plus 5 is 10. See that? Now, if you apply the same pattern, plus 1, plus 2, plus 3, plus 4, plus 5, with a chair, what do you get? Plus 1, plus 2, plus 3, plus 4, and plus 5. So C plus 1 is a D. H plus 2 is J. A plus 3 is D. And I plus 4, I is 9. 9 plus 4? 9 plus 4, how much is that? 13, correct? 13 what? M. R is 18 plus 5, 23. So W. So D, J, D, M, W must be the code for share in this lamp, in this method. So table, if it is called as UCEPJ, then share must be called as DJDMW. Okay, so now we look at this question here. What kind of pattern they have used here? In a certain code language, Roman is called as MZLNQ. Roman is called as MZLNQ. So we'll write it over here. Roman MZLNQ. So R is 18, O 15, M 13, 1, this is 14, and 13, and this one is 26, this one is 12, N is equal to 14, Q is 17. What kind of pattern we have here? 18 became 13, so what's minus 5, right? And 15 is 26, so what is the difference? 15 plus 11, 11 is 26. And this is minus 1, 13 and 12. So 1 and 14, so that is plus 13. And 14 and 17 plus 3. So it is minus 5 plus 11 minus 1 plus 13 plus 3. We don't see any kind of pattern there. However, we copy and paste the same pattern for the given word English. Let's see what happens. English. How do we copy and paste the same pattern? Because number of letters are different. That means here 5 letters. Here, how many letters are there? 7 letters. But anyway, we'll try that. Minus 5 plus 11 minus 1 plus 13 plus 3. And these 2 letters we have no idea. But let's look at the answer choice. E minus 5. E is 5th letter. 5 minus 5 is 0. 0th letter would be what? A is the first letter, 0th letter would be the letter before that, that would be Z. And Y would be before that, X would be before that. So that's minus 1, this is minus 2. So, well, E is 5, 5 minus 5 is 0, that is Z. And N plus 11, N is 14, 14 plus 11 is 25, 25 is Y. Now, look at the answer choice. Is there any answer choice starting from Z, Y? No answer choice is starting from Z and Y. That means this pattern doesn't work for this question. You have to think about something else. Is there anything else? Check it out. Any other pattern possible? Can you figure out any other pattern? I'm pretty sure at least some of you have spotted it out. I appreciate those who have the answer by this time, or at least the pattern by this time. Okay, let's check it out here. Now, we have to really think about how they become a pattern. What I try to invite your attention is, here it's R. R is 18. And here we have a 17. So, see this? R is coded as Q, but however, the position is here. This is the first letter, and the code is at the last. And second letter, 15. So it is 18, 18 minus 1, 17. So this is 15, 15 minus 1 is 14. And M is 13, 13 minus 1 is 12. Then A minus 1. A is first letter, 1 minus 1 is 0. 0th letter is 26. Or A, you can take it as 27th letter. 27 minus 1 is 26. That's correct. So A, you take it as 27. Or it can be 1 as well. Doesn't matter. So anyway, A, the letter before A is Z, something like this. Before A, it is Z. Before A, it is Z. Now, next one, N. N minus 1 is M. See that? It is crisscross pattern. Now, if you apply the same pattern here, see that? The code for H minus 1 must be the first letter here. And S minus 1, that's R. I minus 1 is H. L minus 1 is K. And G minus 1, F. And N minus 1 must be here. N minus 1 is M. And E minus 1 is D. So GRH, KFMD. GRH, KFMD. GRH, KFMD. So this is the answer choice. So GRH, This is not the answer. GRH KFND, that is not the answer. GRHFH, actually it is GRHKF. GRH, this is not GRH, GRF. So that's the only possibility we have. That's the answer. So this is how we deal with coding decoding type of questions. Well, this is another variety of coding decoding question. See that? Tin Tan Ton stands for live the life. So Tin Tan Ton, live the life. And Tan Kun Man stands for life and me. Tan Kun Man, life and me. Then Ton Kot Nas, live your dreams. So these are 3 statements given, and we have 3 code statements given as well. The question, what will be the code for live in this code language? So what is a code? How do we find out? So live is here, and live is here in the statement as well. So now you'll compare these 2 statements. These 2 statements, live is the only common word. Live is here and live is here. Other words, what we have here, the life. The life is not here. That means live is the only common word between statement number 1 and statement number 3. If statement number 1 and statement number 3, now we compare the codes of statement number 1 and statement number 3. Any code common here? Which is a code common? Ton is common. Ton is common. Any other code common? Tin is not here. Ton is not here. I mean, TUN, ton, it's not here. Ton is here. Ton, right. All right, so ton, that's the only code common. And this is the only word common. This is the only code common. So naturally, the code for live must be TON. This is straightforward question, pretty simple question. Next one, 23. This is pretty much what direction sense question. Ajay facing east, travel 10 kilometers straight. So Ajay is facing east. So what are the directions? We have to mark the directions. Standard directions are north, south, east, and west. And well, in the standard directions, it's clearly given that Ajay is facing east. Ajay is facing east. From there, Ajay the facing east, and Ajay walked for 10 kilometers straight. So Ajay walked 10 kilometers straight. He's facing east and he walked for 10 kilometers. Then he took a left turn. From this position, took a left turn means he must be going north. He's going north for 5 kilometers. And then he took another left turn. From this point, he took another left turn and he just went this way. How many kilometers? Further 10 kilometers. So he must have reached here because this is 10 and this must be 10 as well. So it is parallel lines. Now the question, how far is from the starting point? This is a starting point. This is a starting point. Now how far? Well, he's exactly at the same point north. Exactly parallel to the same point north. So this distance must be the distance here as well. So how many? 5. So 5 kilometers. The answer right here, 5 kilometers. How far is from the starting point? 5 kilometers. If they ask for the direction, definitely you can say that it is 5 kilometers north. But this question, they haven't asked for the direction. So this is just 5 kilometers. That's a distance. Now we have 24, question number 24. Well, I'm facing east. This is another question which is related with the direction sense area. So this person, let's say it is you or myself, doesn't matter. We are facing east. From there, I turn 180 degree in the clockwise direction. So which is a clockwise? This is a clockwise direction. Clockwise or anti-clockwise, if it is 180 degree turn means clockwise or anti-clockwise, it is same feel. Okay, anyway. So this is clockwise turn, 180 degree. So this is the first position this person is facing. And after 180 degree turn, this person is facing just the opposite direction. So that's the second direction. So this is west and this is east. So this is the point of rotation, right? So from here, that person is facing east Now that person is turned 180 degree facing west. All right, so well, I'm facing east. I turn 180 degree in the clockwise direction and then 135 degree. From here, 135 degree in the anti-clockwise direction. So this is the anti-clockwise direction. So from here, 90 degree up to here, 135 degree means this direction. So from this point, this is what? Pretty much 135 degree. This is 180 degree. 180 degree. So now I'm facing this direction. What is that direction? This is east and this direction is south. What is in between south and east? That is southeast. So that is answer. Another interesting question. In the English alphabet, which letter is exactly between 6th letter from the left and 10th letter from the right? Let's take a look at that. Which is the 6th letter from the left? A, B, C, D, E, F. So 6th letter from the left is F. When you look at the position values, you see that A is 1, B is 2, etc. So 6th letter from the left is F. 1, 2, 3, 4, 5, 6. And we need to have the 10th letter from the right. Okay, so 10th letter from the right. Which is the 10th letter from the right? Well, actually it is Q. If you know that, it's pretty easy. Otherwise, just look at this way. 10th letter from the left. So if you want, you can count as well. Q, R, S, T, U, V, W, X, Y, Z. So from the right, 10th letter. First letter, second, third, fourth, 5, 6th, 7th, 8th, 9th, 10th. So that is correct. Q is the 10th letter from the right. So the question is, which letter is exactly in between the 6th and the 6th letter from the left and 10th letter from the right? So now, which are the letters between 6th letter from the left and 10th letter from the right? Or how many letters are there between? That is what you have to think about. The position value of Q from left is 17. The position value of F from the left is 6. 6 and 17. How many letters between them? 6 plus how much is 17? 6 plus 11 is 17, right? However, how many letters between? There must be 10 letters between. Okay, so let's take a look at that. Which are the 10 letters? The 10 letters are, after F, we have G, H, I, J, K, L, M, N, O. Count it. How many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So O, P. 10 letters are there. So out of this 10 letters, the question is, which is exactly in between? Well, exact between this 10 letters is this point right here. That's exact between. So there's no letter. There are 2 letters in between. If you take 2 letters in between, that is K and L. The total number of letters in between, if it is an odd number, you get exact letter in the middle. But in this case, it's an even number. How many letters? 10 letters. So that's an even number. So you don't get the exact letter in between. So they are asking for exactly in between. So that's a question. So there is no such letter. That's the answer. There's no such letter. Question is relatively simple. Only thing you need to read and understand the question. This type of questions comes from the area called letter series. So there is number series questions, letter series questions, analogy questions, a lot of different varieties of questions are there. And we have discussed many of these areas. Of course, this area, logical reasoning, is pretty vast. I think you have to refer some, useful books for this. I'll give you some suggestions and I'll communicate with your course coordinator or class teacher. He may give you the suggestions through WhatsApp. So that's the best way to deal with this kind of area.